Hello everyone. Today we are going to learn the shape optimization using the SOLIDWORKS simulation step by step. So first create a model, part modeling. Select the front plane, sketch option. Create a plate. Provide dimensions. Hole diameter 10 mm. Position of hole from the side 15 mm. Construct the figure. Exit from sketch. Go to the feature and create a model using extrude command. Using mid plane, thickness of plate is 10 mm. Press OK. For this plate, we are going to develop a shape optimization. Select simulation or unable to simulation. Select a new study. Click on a topology study. Numbers of options are available. Thermal, buckling and fatigue. Select topology study and press OK. Then first step, right click on the part, apply and edit material. Select the proper material. Different types of materials are available. Select the plain carbon steel, apply and close. Next step, after applying the material, second step, there is a fixture. Apply fixture, right click, fixed geometry, select a side or face, fixed one. This is the fixed geometry and the old positions are also fixed. You can see the face 1, 2, 3, face 1, 2 and 3 are selected for the fixed geometry. Press OK. Next step, apply the load. Right click, use the pressure Also, we can use the force, torque, gravity, centrifugal force. We select the pressure, select the phase, then value. First, initially select the unit megapascal. So we can select the unit psi, Newton meter square. So megapascal unit, and the load it is applied 5 megapascal. So pressure value it is a 5 megapascal. Then press OK. Next step is a goal and constraint. So right click. So for the shape optimization, we can use the base stiffness weight ratio, minimize maximize displacement we can check. Also the minimizing the mass. For the shape optimization, we select the minimizing the mass. Also provide the displacement constraint. Scroll down, click on the mass constraint. So in this tab we can see the current mass of this plate is a 0.436 kilogram, means 436 gram, and final after the simulation the final mass is 0.305 kg, means 305 gram. You can change the percentage 30, 35 for the reduction of mass constraint, then press OK. Next, manufacturing control. So you can select the manufacturing control as per the manufactured part or plate. So different types. We select the specify the symmetry. We select the front plane exactly at the mid plane half symmetry, and then finally mesh. Right click on a mesh, create a mesh. For coarse one required less time, fine one required the large time for the simulation, but it gives the better result. For the quick result, we select the coarse mesh density. In this, the numbers of node points are selected for the analysis. Divide into the numbers of points. Press OK. Now you can see the mesh quality. After that, click on the run this study. It will take us some time to generate the result. To view the graph, you can use the view data and graph. Click on this tab. So for the minimizing the mass, so first graph, click, you can see the numbers of iteration. The graph on the x-axis numbers of iteration, and y-axis there is a minimizing the mass in kilograms. So in numbers of iteration, the graph will reduce the weight. Second, displacement. So in this graph we can see the iterations and the displacement target. Now you can see the numbers of iterations are 17. So minimizing the mass, the value is a 277 gram, and the mass targeted, it is a already decided 283 gram, but actually current value it is a 318 gram. So numbers of iteration 18. So numbers of iteration will reduce the mass and the displacement, which shows the current values. So you can see iteration number 19, again there is a reduction of the mass into the 315. So these are the numbers of iteration for the final value to achieve the final value of weight reduction. After 25 iteration, you can see the mass reduction, it is a near about the targeted value, that is a 297 gram, and targeted value is 283 gram.